In this video, I will be going over exercise 9.11, which reads, the rotating blade of a blender turns with constant angular acceleration of 1.5 radians per second squared. So from right there, we know it's going to be a constant angular acceleration problem. So we're going to go over here to part A, which says how much time does it take to reach an angular velocity of 36 radians per second starting from rest. So right here, I have listed what we know. We know that the angular acceleration is constant, and it is 1.59 radians divided by a second squared. We know that the final velocity will be, the final angular velocity will be 36.0 radians squared. I mean, not 36.0 radians per second. And we know the initial velocity is 0. So right there, we pull out this motion equation from constant acceleration. And then, so we know we're looking for time, which is going to be right there. So we rearrange the equation so we can get time in the end. And then I plugged in the numbers, the well-known numbers that we know. So t equals 36 radians per second minus the initial velocity, or initial angular velocity, which was 0, divided by the acceleration, which is 1.59 radians per second squared, which gets us at t equals 22.6 seconds. Then we move on to part B. Part B reads, through how many revolutions does the blade turn in this time interval? So once again, we have a constant angular acceleration problem, so we can use one of the motion equations, which I have presented right here. And we don't have to rearrange at all because it's already, what we need to find is the amount of revolutions, which is already on the correct side. So then we go about this by plugging things in. We know that it starts from rest, so the initial is going to be 0, or initial position is going to be 0. And then it also does start from rest, so the initial constant, the initial angular velocity is also 0 right here. And then we plug in those numbers right here where it says 1/2 times the acceleration times the time squared, which is 1/2 times 1.59 radians per second squared times 22.6 seconds squared, which was the number that we got from this part, from part A, which equals 408 radians. But we're not there. We're not done yet. We move on to, it's asking for revolutions, which we move on right here. So we get 408 radians and multiply that by 1 revolution over 2 pi radians, which gets us 64.9 revolutions. And that is the answer to part B, and that is all of 9.11.